Alright, at this point we've made some good progress putting the basic system together. Let's go ahead and make some changes to the front panel to make it more usable than it is right now. As you've had a chance to experience yourself at this point, when you want to change one of the input parameters, you click in the front panel control box, type in a new number, or you could push the little scroll wheel if you wanted to, but if you're trying to jump to some new value fairly quickly, that would take some amount of time. So the point of system 2 now is to take our existing block diagram and pretty much leave alone, but just make some changes to the front panel. So in particular, I want to replace this numerical control with a pointer slide. You can use either a horizontal or vertical pointer slide for that purpose. Of course, you can move it around. You can resize it, and you can also change its behavior, such as setting an upper limit. In this case, I'm changing the upper limit to 20. If we wanted to generate many more samples than that, for example, if we wanted to have an upper limit of 1,000, it's not a problem. Of course, we can't actually display more than about 20 or so with the Boolean indicators the way they're set up, but they are in fact there, because if we look at the measured bit error rate, we see that for a large number of samples, that measured bit error rate, or BER as it's commonly called, is very, very close to the specified bit error rate. And if you right click on that control and select properties, you can find all sorts of additional things you can do to set up the behavior of that slider control. Well, let's do the same thing to the BER value. Let's also replace that with a pointer slide. In this case, I'm going to use a vertical slide, since commonly when you're looking at plots of bit error rate versus signal to noise ratio per bit, and you'll be getting into these in a little bit in your studies, we always see that BER value showing up on the vertical axis of the graph. Now, one of the things I want to point out here is that you can see the exact value as you run the pointer. If you make the digital display visible, of course you see what the pointer is exactly, but the nice thing here is that when you want to, you can dial up an exact value. For example, if we wanted to dial up 174. So it's very convenient to be able to use either style of control as needed. Now, another thing I want to comment on here is that you can make these kind of style changes to other things. In this case, the Boolean indicator. If we wanted to fit more Boolean indicators on a given amount of space in the front panel, that's pretty easy to do. All right, another enhancement I want to look at is the notion of visualizing this bit error rate, the Boolean type signals as a waveform diagram. So there's the waveform as it appears in the block diagram. Let's just try doing a quick connection from the waveform plot to the Boolean array, or what I call the bit stream, and we've got a data type conversion problem there. Well, if you look under Boolean, you'll find a conversion from the Boolean data type to integer data type, where the true value maps to a 1 and the false value maps to 0. Alright, so then we get something where we can view it then as values as a function of time. Now what I'm trying to do here is adjust the burr and see the changes in the waveform plot. Let's see if we can get a little bit better control over the exact value that we're specifying for bit error rate. With this logarithmic style mapping, you can do similar kind of things in terms of setting minimum and maximum values. And especially when you stretch this out, you'll see that now with this log mapping technique, you can specify a value fairly accurately over a very wide range, in this case a 1,000,000 to 1 range. Now in order to see the waveform actually responding to that specified bit error rate value, let's go ahead and connect the waveform plot to the error bit stream. Alright, so if we push the burr up just a bit, maybe a little bit higher. Alright, there we're starting to see some errors cropping up. That would be a value of 0.01. Now, as we generate many more samples, then we start to see more errors pop